let's look at this next question. This time you have two planes, okay? Two planes, they are going to intersect at some point, and that the intersection of two planes is going to give you a plane, a line, a straight line, okay? And you are to find an equation of a line that's parallel to that line of intersection. So there's like two planes that's okay. Does that look like two planes intersecting? So this one plane and another plane, and they're intersecting at this single line. And what you're trying to do is you want to construct another line that has the same direction as this guy, and it has to pass through 2, 1, 3. Is that good? All right. So one way to do this is to actually find the intersection of these both, okay? And then from there, you can read off the direction of the line and try that. And I don't think that will be that easy. Yeah, I don't see an easy way to find the intersection of the two things and write it as a symmetric form. Yeah, it's not so straightforward. Okay, so instead what I'm going to do is to think about the perpendicular vector of one plane, okay, and the perpendicular vector of this plane. Now if you bring this vector over to the point of intersection, you have this line and one vector going that way and another vector going that way. So there's this line and one vector is going this way and another vector is going this way. Now, can you see the relationship between the three vectors? What do you see in the three vectors? The direction of this line is going to be perpendicular to both of these, right? That's because these vectors are already perpendicular to each of these planes, and the line is embedded inside the plane. So anything that's straight that's inside the plane is going to be perpendicular to the normal vector. Agreed? So that means the direction of this line that we're about to find is going to be a perpendicular vector to both of these vectors. How do you get a perpendicular vector if you're using two vectors? Cross product. So that's what you do. Okay? So the solution will require you to calculate the cross product of the normal vectors of these. Okay. All right. So give me the normal vector of this one.
2, -1, 4.
2, -1, and what's in front of 2?
0.
0. Okay. And what's the normal vector to this guy? What?
1, 1, -3.
1, 1, -3, right? Okay. So now you have to calculate the cross product. So we're going to do 2, negative 1, 0 crossed with 1, 1, negative 3. And the way you calculate that is you put ijk, and you put 2, negative 1, 0, 1, 1, negative 3. And then you expand with respect to one row or column. So it would be I with negative 1, 0, 1, negative 3 minus j with 2, 0, 1, negative 3 plus k with 2, negative 1, 1, 1. Which gives me positive 3i. It's negative 6, but it's a positive. This gives you negative 6, but there's another minus, so it's positive. And 2, so you get positive 3k. So that's your direction vector. And you're pretty much done, because now you can say that the answer is x minus, it passes 2, 1, 3, so that's going to be x1, y1, z1. And the formula for the line equation is this. Right. So that's going to be x1, x minus 2 over 3, y minus 1 over 6 equals to z minus 3 over 3. Done. That's the answer. While this is perfectly fine, you could also multiply by 3 to simplify this a little bit. So alternatively, out answer will be x minus 2 over 1 equals to y minus 1 over 2 equals to z minus 3 over 1. And you go from here to there just by simply multiplying by 3 to reduce the denominators. But that's not necessary. I'm just saying some people like to have smaller numbers. That's one way to do it. Okay? Okay. Any questions? Yeah?
Yeah, I just have a quick question. So I know that's symmetrical form, correct?
Yeah.
So wait, can you explain the difference between symmetrical form and
Oh, yeah.
plane?
So you could alternatively, you can write the answer in terms of parametric form. And the way you do it is just simply set equals to t and solve for x, y, z.
Okay.
Yeah, so if you multiply them, that's multiply by 3, add 2, you get x equals to 3t plus 2. Y would equal to 6t plus 1. And z would be equals to 3t plus 3. Or you could do it here too. And the only difference is now you have 1, 2, and 1 instead. So there are many different ways to write down the line equation, and all of them will be correct. Yeah, the difference between this one and still another out would be x equals to t plus 2, y equals to 2t plus 1, and z equals to t plus 3, which is what you would get if you said this one equals to t, is that if you think of these as like particles moving on a straight line, this just moves 3 times faster than this one. But the trajectories are exactly the same, so they describe the same line equation. Okay?